Hello guys, and welcome to today's tutorial. So this is going to be a quick one. We are going to be examining Bessel's equations and Bessel's functions. So there's usually past question that occurs in this form. So this is the past question. Let's look at it together. So in the first part, we are to write down the expression for Bessel's function for the first kind of order n. Then secondly, write out the first few terms of j1 over 2 of x from above and prove that j1 over 2 of x is equal to the square root of 2 all over pi x times sine x. Then the third part is that we have to prove that j minus n of x plus jn of x equal to 0 for n equal to the set of odd numbers, as you can see, from 1 down to whatever the odd number may be. So this is just like the general set of odd numbers to r plus 1. Okay, so we are going to divide this particular lessons on Bessel's functions into 3 parts. So in each part, I'm going to be taking us on the solution of each of the numbers that we are given here. So let's dive into the solution for this first part. Then in the second video, I'm going to do this, and in the third video after this one, I'm going to do it. So this is part 1. So please, after you watch part 1, dive straight to part 2 so that you can see the solution of the second part and the third part respectively in part 3. So let's dive in together. Solution. Now we want to write the expression for Bessel's function of the first kind of order n. So how exactly do I go about this? First of all, we need to recall that the Bessel's differential equation is given to us as x squared d squared y by dx squared, then plus x dy dx, and plus x squared minus k squared, and you now have your y equal to 0. So this is the Bessel's differential equation. When we solve this particular Bessel's differential equation, we are going to get our solution in this form. So on solving that by Frobenius method, when we solve this particular Bessel's equation by Frobenius method, the answer that we got, which I'm not going to do now, maybe in another video in the future, was y equal to, we have an arbitrary constant, we have a, we have jk of x, and we now have plus b j k j minus k of x. So we got these solutions, okay, for the solution to this Bessel differential equation up here, and this particular function that you're seeing is called the Bessel's functions. Okay, Bessel's functions of the first kind of order k. Bessel's functions of the first kind of order k. So this is how you're going to write it. So jk of x, okay, if we expand it, this is what we're going to get. We're going to get an x all over 2 raised to the power of, we have k, then we now have summation, we now have m equal to 0 down to infinity, minus 1 raised to the power of, you have an m, you have x raised to the power of 2m, all over, we have 2 to the 2m, we now have m factorial, then we now have gamma of m plus k, and now have plus 1. Okay, so this formula is still very much the same to somebody writing it as j of k, jk of x is equal to, you have summation m equal to 0 to infinity minus 1 raised to the power of m, and you have x all over 2, everything raised to the power of 2m plus k, then divided by, you have m factorial, then gamma of m plus k plus 1. Okay, so the concept or the idea behind this formula translating to this one is, if you can picture this, okay, these ones, they have the same indices, that's 2 raised to the power of m. So this is an x over 2 raised to the power of sorry, the indices is 2m, so x over 2 all raised to the power of 2m. So when x over 2 all raised to the power of 2m interact with x over 2 all raised to the power of k, by law of indices, x over 2 all raised to the power of 2m times x over 2 all raised to the power of k becomes x over 2 raised to the power of 2m plus k. And this is another way of writing the Bessel's function, okay, of the first kind of order k. Now, if we want to write it in terms of n, if we want to write the Bessel's functions in terms of n, which is the requirement of the past question. Now, you permit me, for the purpose of these tutorials and for the purpose of generality, to stick with this particular pattern. I'll prefer to stick with this particular pattern of writing my Bessel's function of the first kind of order k. I'll prefer to stick with this pattern than this pattern, and my reason will become evident later on, but they are both still the same thing. Now, what we are going to do is we are going to write it like this. Okay, so for Bessel's function of first kind of order n, so in this case k is tending to a particular number n. Okay, so if k tends to a particular number n in our formula over here, so what we are going to do is we are going to say jn, okay, of x is now going to be x over 2 raised to the power of n. Okay, are we together? And we now have summation m from 0 to infinity, and we now have minus 1 raised to the power of m, and you now have x raised to the power of 2m, and all over you have 2 raised to the power of 2m. You have your m factorial, then you now have your gamma of m, and plus n, then plus 1. So this is the expression for the Bessel's function of first kind, okay, of order n. So we can begin to substitute different values of n, such as 1 over 2, 0, 1, and so on and so forth, to find Bessel's function of 0 order. When n is equal to 0, we call it Bessel's function of 0 order. When n is equal to 1, we call it Bessel's function of 1 order. And when n is equal to 1 over 2, we call it the half order Bessel's function, or Bessel's function of half order. So this is the expression for our Bessel's function, and we are going to analyze the solutions to other problems in your past question. So I want you to like this video and subscribe to this channel, and hit the notification bell to stay updated, and don't forget to share to your friends as well. So one other thing before I close for today, I also want to show you that when we are dealing with the Bessel's function of negative order, first kind, then you have the negative n order. It's still the same thing as you having x over 2, then you now have minus n, okay, and you now have your summation m 0 to infinity minus 1 raised to the power of m, then x raised to the power of 2m, all over you have 2 raised to the power of 2m, you have m factorial, then you now have your gamma function, which is still the same thing as gamma of m, then instead of plus n it will be minus n, and you now have plus 1. Is that okay? So this is for negative order, so just in case. So this is like a brief introduction to Bessel's function. The most important thing is your ability to memorize this particular formula, and if you can actually discover some patterns in the formula, it will make it easy for you to memorize it. Now the derivation of these formulas is not a child's play. It's actually intense, and it involves your knowledge of power series, precisely Frobenius methods of solving differential equations. And when we actually made some substitutions, we were able to come about our what we call our recurrence relation, and by solving the recurrence relation we were able to obtain these particular coefficients, okay, as my jk of x and j minus k of x. So we obtained that through Bessel's of Frobenius method, and I will in the future create a video to describe how that was done. But for the purpose of now, you should just get introduced to Bessel's function, okay? And it's a function that occurs like pretty frequently in engineering. So we always see this kind of differential equation occurring frequently in engineering, and what we want to do is we want to just generalize the solution so that we are not going to be solving it all the time, and that is where the Bessel's function comes in handy. So those of you that are into perhaps electrical electronic engineering, signal processing, and so on and so forth, you will encounter a lot of Bessel's differential equation in advanced points in your careers. So you are going to find it very handy to at least learn how it works and learn how to go about it and learn how to work with it. Definitely it has a graph, it has a curve, and you should check or look up the curve on the internet, but I'm also going to do that in the future video. So for now, this is the mathematical expression for Bessel's function of the first kind of order n. So this is the expression that we're going to be working with, and we're going to use this as a basis to solve the remaining questions that are in this particular past question. So thank you very much for watching. Stay tuned and stay blessed till the next video. Bye.